We've built a model, schooled it, shrunk it, and served it. But there's a question we keep dodging. How do we actually know it's any good? And once it's good, how do we keep it safe?
This is the capstone. Everything before was about making a model. Today is about trusting one. And that breaks into 4 questions. Can you measure it? Can you rely on it? Does it hold your values? And can you steer it?
Let's start with measuring. If I've got a finished model, what's the first thing anyone does to score it?
You give it an exam it has never seen. We call that a held out test. Questions kept out of training so the model can't have memorized the answers. Bundle thousands of those together and you get a benchmark, which spits out a single comparable score.
So, a higher benchmark number just means a smarter model. Easy. Why isn't everyone happy with that?
Because benchmarks are easy to fool. The first problem is data contamination. These tests live on the public internet, and if the test questions sneak into the training data, the model isn't reasoning, it's reciting. The score looks brilliant and means nothing.
And I imagine if a benchmark becomes famous, people start aiming straight at it.
Exactly. The moment a benchmark becomes the thing everyone competes on, teams tune specifically to beat it, and a high score stops reflecting real ability. It's the classic trap. The measure becomes the target, so it stops being a good measure.
Multiple choice is also kind of artificial. Half the things I actually ask a model don't have one right answer. How do you grade those?
Right, there's no answer key for write me a poem or summarize this contract. So you bring in judges. The gold standard is human evaluation. Show people 2 answers and ask which is better. It's accurate, but it's slow and expensive.
Humans don't scale, though. You can't pay people to grade millions of answers. Is there a shortcut?
The common shortcut is to use a strong model as the grader. We call it LLM as judge. One capable model scores another's answers against a rubric. It's fast and cheap, but it inherits the judge's blind spots and biases, so you anchor it against human ratings to keep it honest.
Okay, so suppose a model aces every test we throw at it. Does that mean I can actually rely on it in the real world?
Not necessarily, and this is the distinction people miss most. Capability is can it do the task? Reliability is does it do it every time? A model that's right 95% of the time is impressive, but that's one wrong answer in 20.
1 in 20 doesn't sound terrible for, say, brainstorming ideas, but I can see it being a disaster somewhere else.
That's the whole point. A brainstorming partner can be wrong sometimes. A system reading a prescription or approving a loan cannot. And worse, these models can be confidently wrong, stating a made-up fact in the same calm voice as a true one. That confident but wrong failure is what makes reliability so hard.
So measuring is hard, and reliability is harder. Now the scarier question. How do we make sure the thing actually behaves itself?
Alignment is the work of making a model helpful, honest, and harmless. Helpful means it actually does what you ask. Honest means it doesn't fabricate. Harmless means it won't help someone cause real damage. The hard part is that nobody can write those 3 down as exact rules.
We talked about the training methods in an earlier episode. Remind me how they connect to these values.
2 main ways, and the why is what matters here. With learning from human feedback, people pick the better of 2 answers, and over millions of choices, the model absorbs what we collectively prefer. The framing to remember: you're not programming values, you're teaching them by example.
But human judgment is expensive and a bit inconsistent. Is there a way to make those values more explicit?
That's the idea behind constitutional AI. You write the principles down as a short constitution, then have an AI critique and revise answers against those written rules. It makes the values explicit and auditable, instead of buried in a million quiet human clicks.
Teaching values is one thing, but how do you find the cases where it all breaks? You can't predict every weird prompt.
You attack it on purpose. Red teaming is hiring people and other models to deliberately trick the system into doing something harmful so you find the cracks before users do. Every failure they uncover becomes new training data to close that hole.
All of this still treats the model like a black box, though, right? We're testing the outside. Can we ever look inside?
That's the frontier called interpretability, the effort to read what's happening inside those billions of weights, to find the internal patterns for concepts like deception or a specific fact. It's still early, but the dream is to verify a model is honest by inspection, not just by testing its outputs.
So, pulling it together. Measure it, check it's reliable, teach it values, probe it, and look inside. What's the one line to walk away with?
The whole episode lands on one idea. A model you can't measure and can't steer simply isn't safe to deploy. Capability gets the headlines, but trust is the engineering. Get measurement and steering right, and you've got something you can actually stand behind.